Joining me now for my next guest is David Chiu. He's from TRI in Taiwan. Nice to see you, David.
Nice to see you.
Yeah, thank you for coming in. So, you've been doing quite a lot of developments this last year or two on AI.
Yes.
You've been using AI for automatic programming for a couple of years now.
Correct.
But let's start off with that. I mean, how is that progressing? How quickly can you do automatic programming, and how much of the programming can you actually achieve using AI?
Okay, so for TRI, we have been on AI programming for a long time. It's more than 2 years experience. And for us, we also cooperate with NVIDIA, so we use their very good hardware. So we use their GPU to improve our AI programming, AI verification, and AI fine-tuning.
Oh.
So currently, I would like to say AI is still in the beginning, but not mature yet. We are still working on it, but it's getting better and better every day because AI need to keep training.
Right.
So currently, I can see we have like at least 75% improved than before. So it means you can save at least 75% time for programming. Also, it's a lot of it's much accurate than before.
Right.
So our AI system can recognize those components, no problem. At least 80%, you can put it on the same shape, then size. So we can put the library on it, and they will automatically fine tune. And we also can send the data to the repair station, so they can automatically verify it's good or no good. If you learn more, it will become more accurate. So it will save you a lot of labor and the operator time to handle those machines.
Right. So basically you're saying that it can do 75%, so it's doing it to 75% accuracy. The other 25%, basically the operator has to manually program it as he's done before.
Yes, correct.
Okay, that's fine. It's using the NVIDIA H100
GPU.
chip, which is really powerful, and as you say, the more you teach it, the more you learn.
Yes.
One of the systems you're using though for the verification and checking though is you're using like facial recognition type cameras.
Yes, similar to that one. So just like the Face ID. So our system will, according to the CAD location, to find what the component it is, and give you the proper model library and put it on. So it will analyze the pin and the height for you in the beginning. So you save a lot of time to program it.
Right, so if it's doing that, it can recognize, for example, the band colors on resistors and things like that?
Yes, it will.
Yeah?
Yeah,
okay.
According to the color pixel.
Right. Yeah, okay, that's good to know. And then, of course, it checks the offset to make sure, you can set it to IPC 1, 2, or 3 or whatever.
For our software, we have IPC class 1, 2, 3 for the 2D, and we have the 3D for IPC class 3. It's all follow the IPC regulation, and you also can use user-defined to do it by yourself if you think IPC class is not really fitting your production. You also can modify it by yourself.
Right, okay. So you said you're using AI also for tweaking. What did you mean by that?
So for traditionally, a lot of people they only use like programming like AI, but it's not really AI. You have to merge like CAD file and a Gerber file. So our system can just use CAD file to find out all the parts for you.
Okay.
And, so it means when you're doing the tweaking, okay, customer usually just by the operator, the programmer, they have to tweak by themselves. So you never know what's the good parameter for that, what's the tolerance you want to use. But our AI system will according to your golden board.
Right.
Okay, so it means the first board, the first article board has to be very accurate.
Yes.
So we use that board to run a couple times. So our system will get the proper number for all the settings. So it will keep tweaking for the first board. So if you have more board run, and it will just like correct the number.
Yeah.
After you do like 3, 4, 5 boards later. Yeah.
Okay. So you use the golden board principle, so it's very accurate, but then it changes it.
Yeah.
To what sort of degree of accuracy does it inspect?
What do you mean?
What sort of degree of accuracy do you get from your system?
Degree?
Yeah, I mean, to plus or minus, 2 micron or something like that. I mean, what is your?
We check it by 1 micron.
1 micron.
Yeah.
Mm-hmm. Okay.
So by micron, but it just depends on the IPC class and how big is your pad.
Right.
Yeah, it
right.
depends on your pad.
Right.
Yeah.
Now, one of the other fairly unique things you're doing is you're offering a data sharing system using AI
Yes.
to your customers. So
Correct.
this is an opt-in program. So if they don't want to do it, they don't have to do it. But if they want to opt in and share their data, then they get the benefit of all the other people who've shared data.
Yeah.
So which pretty much gives you the same capability as the tier one. Because the difference is the tier one companies, they have lots of factories, lots of lines, and they get the benefit of all that large data lake.
As you can know, TI is a big company, so we have so many customers. So if our customer they want to share with their library, then we have very, very big data for all the customers. So they can share with each other with the existing data. So the new customer, they don't need to spend too much time to develop their own data.
Right.
It will save a lot of time for them.
Yeah. That's a great idea, and I think they get the benefit of everybody else using the system.
Yeah.
Okay. Great. So what's next? What's coming down the pipe that we can expect to see from TRI?
All right, for TRI, we are working on the semiconductor right now. So we have our really high resolution image. So, but that one is the one I cannot tell you too much right now. But our image is much clearer than the existing product right now. So, if you want, you can come to our booth or talk to us. We can show you what's the difference between the traditional 3D image and our new 3D image.
Right.
Yeah.
Okay.
We can down to 1 micron right now.
Right. Okay.
So micron is not the big issue. So.
Right. What size of cameras do you use?
What size?
What size of cameras?
Is a 1 micron.
No, but I mean, are they sort of? Are you going into 25 megapixel cameras?
I don't know the megapixel right now because. Okay. Yeah, because that one is the one I don't know. Yeah. They use the special one.
Yeah.
So, but I would like to say, even though the regular machine, we have 25 micron right now.
Okay.
Yeah, 21 and 25. For TI, we have so many different options. Depends on your budget.
Yeah.
So we have 4 micron, 6.5 micron, 12 micron, 21 micron, and 25 micron.
Okay.
Yeah, okay. And we have the special one. This is the one.
So depending on what you're building,
yes, depends on your needs and your budget and up to your component size. And depends on you are doing like AOI or SPI. You have different choices for us.
Yeah. Great. Well, it sounds like you've got a very flexible stable of inspection machines, and I love the stuff you're doing with AI. So thank you for coming in and telling us about it today.
Nope.